Hi, we are Engineering Brothers. In our previous occasion, we have used our block diagram reduction to solve this block diagram problem over here, and ultimately we have got our transfer function, which is this one. And we do need to record that answer over here. Why? Because that will be ultimately rechecked that whether the answer for both the occasion for our block diagram reduction and the signal flow graph are same one or not. So let us just note down our answer over here, which is quite naturally our CS divided by RS, and the final answer for our from our block diagram reduction will be this one, which is G1 G2 divided by our 1 plus G2H2 plus G1H1 plus G1 G2 H1H2 plus G1 G2 H3 G1 G2 H3. Now we have recorded the answer over here, which is just by using our block diagram reduction. We have got this is going to be a final answer for this given block diagram problem over here, and the answer will be G1 G2 divided by 1 plus of G2 H2 plus G1 H1 plus G1 G2 H1 H2 plus G1 G2 H3 according to our given previous occasion. Now in this considered part, we are just going to use our signal flow graph to solve the same problem over here, which I am just going to consider over here in this given problem over here. Always do remember that if your concepts are not clear, you are not been able to understand all these concepts over here. That is why I keep on telling you the same thing. Do follow our classes, keep following our channel, and that will be the only way to clear or clarify your concepts. Okay? First of all, note down our nodal points over there. Summing point will be 1, this one will be 2, and as the take-up point is present in front of our summing point, that take-up point will be considered as separate node compared with our summing block over here, that has been considered as 3. This summing block will be considered as 4, and this will be our CS. Now let us draw that signal flow graph over here. While considering our signal flow graph, we should draw the signal flow graph over here, and after that we should use our mission gain formulation to have the final transfer function over here. Now quite naturally this is going to be our 1, this is going to be our 2, after that this is going to be our 3, and this one will be our 4, and this one will be our CS, or the output node over here. This is going to be our RS, that is the input for our considered part over here. In between our 1 and 2, we have got the signal of 1 that is been considered over here, as nothing will be mentioned in between our 1 and 2 that actually give us the gain for that particular path will be our 1. In between our 2 and 3, we have got the gain as our G1. This is going to be our G1. In between our 3 and 4, we have once again nothing will be mentioned over here. Now quite naturally the signal for this consideration will be 1. And in between our 4 and CS, we have got the gain as our G2. Now this is going to be our G2. Now follow the considered part for a feedback path over here. Now quite naturally in between our 3 and 2, we have got the feedback path of minus H1 will be considered over here. Now this one will be a minus H1. In between our 3 and 2, we have got the feedback signal of minus H1 that is being considered over here. Why minus H1? Because you can clearly see that the feedback signal do have the negative signal over here. At this summing point, the minus will be mentioned over there. So quite frankly, the signal in this present consideration will be in terms of minus or the negative sign over here. In between CS and 4, in between our CS and 4, the once again the feedback signal for that present consideration will be our minus H2. Why? That you can do require to see that the gain for that feedback path will be H2, and as this is our minus, quite naturally the signal for the considered part will be a minus H2. Now follow up with the same procedure over here once again. In between our CS and 1, this one, the feedback signal for that case will be our minus H3. Why? Once again, from CS to 1, we have got the feedback signal of H3. And why this is minus? Because quite naturally, we have got the negative signal that is entered at our summing point over here. Now, as per our mission gain formulation, we do require to find out first the forward path over here. In this case, the forward path will be considered as P1, and the gain for that forward path will be what? What is the definition of a forward path? It has started from our RS and it has directly ended at our CS. Now, in that case, what is the expression for our forward path? The expression for our forward path will be 1 multiplied by G1 multiplied by 1 multiplied by our G2. Now the forward path will be our G1, G2. Okay? And the next step will be, let us find out the individual loops over here. And what are the individual loops? The individual loops will be quite natural. First, L1 will be considered over here. And what is that? The L1 will be, it has started from 2 and it has ended, it is going to the node 3, and from 3 it is coming towards a node 2. This is going to be our loop over here, and what is the gain for that loop? The gain for that loop will be minus of G1 H1. In our next considered part, we have got the next loop will be this one. Once again, it has started from 4 and it is going towards our CS, and from CS it is coming back towards our node 4 over here. And the gain for that loop will be our minus of G2 H2 over here. Now what seems to be our next loop over here? Just do follow with our node 1 over here, and for that one we have got, that will be considered as our individual loops 3 over here, and it has started from node 1 to 2 to 3 to 4 to our CS, and from CS it is making and come back at the node 1 over here. And what is the loop for that considered path? That will be 1 multiplied by G1 multiplied by 1 multiplied by G2, and it is coming back at our node 1, which is minus of H3. And what is the overall gain for that one? The overall gain for that one seems to be minus of G1, G2, H3. Okay, so these are our individual loops over here, and the next step will be, we should find out quite naturally our two non-touching loops over here, and we can see that we have got only two non-touching loops that are present over here, which is quite naturally our L1, L2 over here. For our two non-touching loop consideration, this is going to be our two non-touching loop. What is that one? The two non-touching loop in this case will be our L1, L2. Quite naturally, you can see that the G1 minus H1 is not touching with this loop of minus of G2, H2 over here. As these two loops are separately placed over here, quite naturally, we have got our 2 non-touching loop in this case, which is quite evidently shown over here. And what is the exact answer for that one? Just simply multiply these two loops over here. Quite naturally, the gain for that one will be G1, G2, H1, H2 over here. Okay? And what is the much needed formulation for our mission gain formulation? The formulation for this mission gain 1 will be output divided by input, which is CS divided by RS, and the formulation for that one will be P1 delta 1. As we are having only one forward path over here, we should find out the delta 1 as well. P1 delta 1 by delta. We can form the expression for our delta just by considering this loop and two non-touching loops over there. We already have the forward path which has been considered as our P1, and in our next occasion we should find out what is the value for our delta 1. The expression for our delta 1 will be 1. Why? Because that said forward path do make the touch with all those given loops over there. Okay, the said forward path is touching all those loops over here. That is why the delta 1 will be 1. If any loop that is not touching with the given forward path, then 1 minus that loop will be considered as our delta 1 over here, as I have repeatedly told you in a previous occasion, or while calculating or while solving the signal flow graph formulations over there. In our next step, we are just going to put that in our given final answer to have the final expression or to have the final transfer function over there, and after that we can make the comment on whether which method is better while solving this given problem over here. I hope you have totally understood up to this one. If you still have any doubts, please let us know in the comment section for better understanding. Do like, do share our videos and keep following our channel. Just wait for my next one. In our previous part, we have got our much needed consideration for our forward path, the loops that have been considered over here, and we do require to put that in our given expression for our CS divided by RS over here. And in our previous step, first we have formed our much needed signal flow graph over here, and just by looking at this given block diagram over here, we have formed first the signal flow graph over here, and after that one, that is followed by our forward path formulation over there, and that forward path will be considered as our much needed important factor for our CS by RS over here. Now in our given expression, as we are having only one forward path over here, that is why we can say that the forward path of P1 will be considered over here, and that forward path will be connected with our delta 1 over here. And what is the expression for our delta 1? The delta 1 will be if that said forward path is, whether that forward path is touching with any given sort of loop or not, that is our considered part over here. And if any loop that has been present with that one over there, then 1 minus that considered loop will be our much needed expression for delta 1 over here. In our next part, we have considered our individual loops over here, and in this case we are having our three individual loops over here, the L1, L2 and L3 over there, and we are having only two non-touching loops that are present over here, and just by using these loops we can form the expression for delta over here. That will be our much needed consideration over here. Now we can erase this signal flow graph over here, as we have already got the final answer for our transfer function, which is CS divided by RS over here. Now let us just solve this type of given consideration over here. But before I go into that, I should note down what seems to be the final answer. The final answer would be output divided by input, which is quite naturally our P1 delta 1 by delta. And what is the expression for our P1? The expression for our P1 will be quite naturally our G1 G2. Now this one will be G1 G2 multiplied with what is the expression for our delta 1? The expression for our delta 1 will be 1. And what is the expression for our delta? Let us find out that one over here. The formulation for our delta will be 1 minus our summation of individual loops over here. In this case, we are having three individual loops over here, which is L1 plus L2 plus L3, and the next sign for our considered part will be 1 minus our individual loops, or the summation of individual loops that are considered over here. In our next part we are having plus, in our next part we are having two non-touching loop that has been considered over here, which is L1 L2 will be there. This is the expression for our much needed expression for our delta, and no other two non-touching loop or three non-touching loops are present over here. Now let us just put that in our given expression for our delta, which is 1 minus the loop expressions are for individual loop we are having minus of G1 H1, L2 will be minus of G2 H2, and the next one should be minus of G1 G2 H3, minus of G1 G2 H3, plus two non-touching loop will be G1 G2 H1 H2, G1 G2 H1 H2. Now if you just take the common of minus in our given loops, this will become plus and all the rest of the expression will become plus. Now quite naturally the answer for that one seems to be 1 plus G1 H1 plus G2 H2 plus G1 G2 H3 plus G1 G2 H1 H2 over here. Now this is going to be our expression for our delta over here. Now let us just put that over here, which is 1 plus G1 H1. At the place of our delta we are putting the expression, this whole expression over here, which is 1 plus G1 H1 plus G2 H2 plus G1 G2 H3, G1 G2 H3 plus G1 G2 H1 H2, G1 G2 H1 H2. These will be considered over here and that has been placed inside our bracket over here. Now this will be our final answer according to our signal flow graph over here, and let us check. You can see this is G1 G2 and that will be multiplied with 1, that actually give us the same answer over here, which is G1 G2, and this one will be 1 plus of G2 H2 plus G1 H1 plus G1 G2 H1 H2 plus G1 G2 H3. Now we are having the same answer for our block diagram reduction and for our signal flow graph as well. And which method is suitable or better for you, let us just, you should decide over here, because ultimately you can clearly see that all these parts are absolutely essential to have those final answer over there and have the final transfer function over here. And for me, if you ask me which method is suitable for me, I always tell you that the signal flow graph is much more easier, because the procedure for that formulation or that consideration will be much more easier, and while solving this type of problem, that will give you the much needed benefit to have the best from answers over here. For me, the signal flow graph will be much more essential or suitable for me to have the final answer for our transfer function over here. I hope you have totally understood up to this one. If you still have any doubts, please let us know in the comment section for better understanding. Do like, do share our videos and keep following our channel. That's it. Thank you and goodbye.
If you like my video, so what are you waiting for? Please do subscribe my channel, hit the bell icon for more updates and stay tuned to the channel. Thank you and goodbye.